are four. In order to accommodate four, we need four boxes. So the four boxes will have to combine together. Look at the contribution. Obviously, the 3D out of five boxes, the first four boxes which is already filled will be together. Cool. Now, the one which I'm trying to tick right now, one, two, three, and four. These four boxes will combine. Okay, one, two, the custom combination. Now, who is the contributor? Who is the who is contributing how many box each to come to form the four? Obviously, D is contributing initially. Guys, very important because it's a strong field ligand. D will contribute. D is contributing initially one. Next, we come to S. S is contributing one. Out of four, two done. We need two more. Who's going to contribute? P is going to contribute. How many? Two. So automatically this will be 3D and this will be DSP2. Okay. Now at this point of time, whatever I marked right now, that will be a proper complex. Why am I naming it to be a proper complex? That's because the 3D thing is here to accommodate what? The 3D there is there to accommodate the central metal atom. The DSP2 with the empty boxes is there to accommodate the ligand. So automatically in this ligand, you will have to draw four arrow marks like this, and under each arrow mark you will write CN, 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 which is nothing but the ligands. Now here, one ligand will fill one box with one pair of electrons. I am done with the filling part. So CN is also done. So complete drawing of the complex is done. Now I'm supposed to write few points. Hybridization we got was DSP2. If the hybridization is DSP2, then the shape, very important guys, remember this. This is not usually used, but it's important. The geometry will be square planar, very important. Square planar. Cool. Okay, for this I'll draw a diagram and show you guys as to how it works. Then magnetic property. Yesterday only I told you. Depending on the strong field ligand and the weak field ligand, you will be able to predict it. In this case, it's a strong field ligand, which means the answer is obviously diamagnetic. Cool. You will get marks for this, but since you guys, since we're explaining square planar for the first time, I'll now didn't we have this in 11th standard? We did not have it. Don't worry. Fine. 11th standard we had SP3, SP2, SP3, SP3D, and SP3D2. If you see, SP3 was there in all the cases. This is slightly different. Cool. So if the combination or the hybridization is DSP2, the answer is always square planar. Do not, that's the whole point of practicing it. Because what we usually expect is hybridization, 11th standard is completely covered. It is not completely covered. It was covered as per the syllabus. And the syllabus did not have DSP2 as a part of it in last year. Okay, so how does square planar look? But before that, identify the center metal atom. Nickel is there. Square meaning four sides, which and also four corners. So draw four arrow marks at the four corners and attach all the ligands. CN, CN, CN as well as CN. Obviously, draw a square bracket and outside the square bracket, copy the minus as it is, 2 minus. I feel that when they ask NiCN for 2 minus, they will make sure that you also draw the diagram like this. Cool. And the CN should not be like this, guys. This is wrong. It is not north. It's not a compass. So it has to be along the corners. Remember that. Cool. I'll give you 2 minutes. Finish off first. This was one of the questions from yesterday's class. After this, we'll finish off CFT. Done. Done. Next question. Ni Cl4 2 minus. Try this. Fast. I'll give you 2 minutes. Then I'll start off. Okay, we'll start. Okay. Was just checking the thing. Guys, whenever they ask you this question, no, NICL4, um, they'll expect you guys to draw this also. Fine, like it's like compulsory for this. Now you'll realize why. NICL is done. Yesterday I gave you the excited state already, Ni2 plus. The excited state was 3D8, 4S0, 4P0. Now obviously you'll draw 5 boxes under D, 1 box under S, and 3 boxes under 4P, 4P, 4S, 3D. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, I'll go cross check. CL is a weak field ligand, so automatically there'll be no change in D because CL does not have the capacity or the strength to combine that one pair of electron. So we will keep the thing as it is. Now you'll start analyzing that. You'll start calculating the complex the ligand. In this case, we have 4 in number. In order to accommodate 4, we need 4 boxes. Correct. So we'll keep the 3D as it is. We'll accommodate 4 boxes. So this is the 3D one. 1 second. Guys, please keep analyzing, okay? That Cl is a weak field ligand. So therefore, there's no combination here. Now 4 done. 1, 2, 3, and 4. So it'll be Cl, 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 as well as Cl. In each of the box, 1 pair of electrons will come and sit. All these things are fine. Okay. But what's the combination? To form these 4 boxes, no contribution from the d orbital. The contribution was there. We started off from the s orbital. How many in number? 1 in number. 1s and 3 p's. sp3. Okay. Now, don't you think compared to all the 4, this was the most simplest combo? That's because it was a weak field ligand and it just came like that. Cool. Next is sp3 done. So I will write the hybridization based on the combo. sp3 is the combination, done. So based on this, you'll also write the geometry. Geometry for sp3 is tetrahedral. Tetrahedral. Okay. Next is magnetic property. Magnetic property is obviously based on the weak field ligand. So it will be paramagnetic. Okay, then whatever the reason is supposed to write, finish that off. Now, how do you draw? Central metal atom is nickel, 1 Cl at the top, 3 at the bottom. Okay. Now, this is one. This also is acceptable. Ni 1, 2, 3, 4. Actually, this only is right. You see, whatever is fine with your college, you follow that. 2 minus. Now, the reason is because since everything is a bond pair, the angle has to look the same. So in the diagram which I drew on the right side, if you see, this angle is more compared to these smaller angles at the bottom. So technically it is not right. All right. But if you look at the left-hand side diagram I drew, all the angles will be same. Cool. Keep that in mind. And there's this concept called as Werner's theory, which will come in that one-page thing. It's there. So please sit and mug up 3 points. Okay, 3 points. Not at all difficult. Like easy scoring. Whether thing it works. Do not ignore that. Now we'll talk about that CFT. CFT is crystal field splitting theory, or crystal field splitting energy also will be asked. Now, how do we identify and how do we solve this? Understand, under CFT, you will only get 2 questions. Okay, both of them are 95% similar. So what I would do is I would learn one properly. Okay, again, guys, I am telling you, don't be over smart and learn both. You guys will end up getting confused a lot compared to any other chapter. Okay, so if you learn one properly, things will always fall into picture in a proper in a systematic manner. Now, what are the 2? First of all, the 2 CFTs which you're supposed to learn is, one is for octahedral complex, octahedral. The other one is for tetrahedral. Okay. One is for octahedral, one is for tetrahedral. Now, I'll also tell you why. If you see, the first question what we solved in yesterday's class, which involved a weak field ligand, I guess. I'm not sure of the question. I think it is COF6. Yeah. This is, yeah, COF6 something. I forgot. Okay. This geometry was octahedral. In today's class, we learned NiCl4 and the geometry was tetrahedral. We just now got tetrahedral. Okay. Now see, both of them are some kind of shape or some kind of geometries. Okay. But the only common thing between both of them is they are weak field ligands. So if it is weak field ligand, one of them is giving octahedral geometry, the other one is giving a tetrahedral geometry. But even though both of them are weak field, why is it giving 2 different complexes or 2 different geometries is a big question. For that, the answer is CFT. Okay. Now what's going to happen? Let's see. Initially, okay, it's a story. Listen here. It's a story. So basically, if I want to use the word complex, it has to be a combination of, it has to be a combo of what? One is the central metal atom here. Okay. The other one is the ligand here. Correct. Now see, if you observe both of them, end of the day, both of them are boxes. And end of the day, in the boxes, both of them have to get filled by something called as electrons. So you think from the central metal atom's perspective. Okay. You are the central metal atom and I am the ligand. Okay. You also have electrons. I also have electrons. I start approaching you with the amount of electrons that I have. Okay. What are you made of? You're also made of electrons. So don't you think one electron and the electron will always repel? Now, when this repels, what's going to happen? There'll always be some kind of energy exchange. Remember that. Okay. Repulsion, attraction, whatever happens, in one simple word of physics, there's always some kind of energy exchange. And this energy exchange was sparked or it contributed because both of us had good amount of electrons, and when I approached you with good amount of electrons, if we repel against each other. Okay. So that's the story here. So initially there'll be something called as d orbitals. How many boxes? 5 boxes. Initially, there's absolutely no energy exchange because I'm not approaching. No. So see, just imagine this part here. Don't you think in step number one, it's completely dominated by the central metal atom? Yes. Until who comes? Until the ligand comes. So in the first step, who is the king? You are the king. Okay. So there's nobody approaching you. You own the place, and you are absolutely fine with all the energies, and you're keeping all the energies to yourself. You're not distributing anything. Okay. Nothing is getting shattered here. That's the whole point. So since nothing is getting shattered, that concept here is called as degenerate. Okay, that concept is called as what? Degenerate. Degenerate. Degenerate d orbitals. Okay, absolutely no change in energy. Now what happens? The ligand approaches. When the ligand approaches, there's something. The these d orbitals get shattered. Okay, shattered in the sense they have to obviously lose some kind of energy. The moment they lose some kind of energy, okay, they get back, they go to a different state. The different state in this case is usually a higher state. I'll repeat that. So initially, when the central metal atom was there, no problem. But the moment I start approaching you with my electrons, what happens? There's some kind of disruption happening. The disruption leads to non-degeneracy. Non-degenerate, Degenerate. Now, if you're asking me, is the complete reason ligands? Yes, the ligands approaching with the electrons only is the reason. Now the thing is, the moment it becomes non-degenerate, okay, you cannot control the d orbitals anymore, which means it is not stable. If it is not stable, it has a lot of chances. In fact, 100% of the times it will split up again. Okay, so first time it did not split up. It went to a different level. Okay, in that level it is not that stable. Because it is not that stable, it will split up. Now listen to the split up. The split up completely depends on the heading. So let's say the heading is octahedral. Okay. Now the split up happens in terms of how many levels? Only two levels. Okay. Again, if you see how many arrow marks did I draw? Two arrow marks. Both the levels are given few names. Okay. What are they? These are nothing but energy levels. Both of them are given few names. One name is called as EG. The other one is called as T2G. Okay, so what is this? Level 1, level 2. Instead of using level 1, level 2, I'll be using EG level and T2G level. And if you see, E is the main letter, G is a subscript, T is the main letter, 2G is a subscript. Fine. Now, which comes on top and which goes at the bottom, that completely depends on the question. So, if the question asked to you guys is octahedral in nature, understand. And most importantly, guys, I forgot to tell one more thing. EG and T2G, no? See, very easy to remember. EG totally involves how many letters? One is E, one is G, two. Therefore, this level will have two boxes. T2G will involve how many? Three boxes. That's your hint. Okay. So what are the levels? Two levels. And if you combine both of them, don't you think it'll become five boxes? And don't you think those five boxes are nothing but this non-degenerate d orbitals? Got the splitter. One is EG level, one is T2G level. EG, you'll count the boxes. T2G, you'll also count the boxes and draw the number of boxes as it is. Fine. No confusion there. Now, what goes on top, what goes at the bottom? If it is octahedral in nature, remember, if it is octahedral in nature, EG goes on top. If EG goes on top, it will obviously carry two boxes with it. Cool. So this is the EG level. Now, one second, I'll draw one dotted line here. Now, what does this dotted line represent? This dotted line will represent the level. It was supposed to be there, but it split up into two different levels. Okay. That dotted line is always that suppose. Suppose it has to be there, but it's split up into two levels. Now, if EG is on top, automatically, who will be at the bottom? T2G will be there at the bottom. So you'll draw three boxes here. Now the naming. Careful with the naming here. T2G you will name. This will also, you will name it as EG levels. Fine. Now this energy you're supposed to calculate. Now how do you calculate? I'll tell you a hint. These two and three boxes got a split from what? From the non-degenerate d orbitals. In the non-degenerate d orbitals, totally how many boxes were there? Five boxes. Therefore, the denominator will be by 5 and by 5 for both the places. Okay, I'll repeat that. This T2G and EG level got split from whom? from the non-degenerate d orbitals, which totally had how many boxes? 5 boxes. Therefore, by 5 and by 5. Okay. Now again, next part of the story. T2G in this case belongs to the bottom, therefore a minus. So obviously, EG belongs to the top, therefore a plus. Now see as to how the story continues. Listen up. Now EG had to overtake T2G to go on top. I'll repeat that. It's a combination, guys. It's a combination between EG and T2G. So if you think from EG's perspective, EG has to defeat these three boxes to go on top. If you think from T2G's perspective, T2G got defeated by how many boxes? 2 boxes. That's the story. So totally, if I ask you, EG defeated how many boxes? 3 boxes. Therefore, 3 by 5. T2G got defeated by how many boxes? 2 boxes. Therefore, minus 2 by 5. You will write 3 by 5 delta naught. Here also minus 2 by 5 delta naught. Now, what is delta naught? Can you see a clear difference between both the levels? The clear difference between both the levels is nothing but delta naught, and the meaning of delta naught is nothing but crystal field splitting energy. So all these concepts ended up in splitting the field, and that splitting resulted in some kind of energy burst, and that energy burst resulted in two levels, namely EG level and T2G level. T2G is at the bottom, EG is at the top for octahedral in nature. Okay, EG had to win over 3 boxes to go on top, which obviously means T2G was defeated by 2 boxes. Since it got defeated, it went to the bottom. Since it went to the bottom, you put a minus. Since EG won, you put a plus. 3 by 5, 3 by 5. Why by 5? Because all the split was, the story started with these 5 boxes. Okay. Delta naught will always represent what? CFSE, meaning crystal field splitting energy. That's the meaning. Cool. Now, what will be the change if the question changes from octahedral to tetrahedral? One second, don't copy. I'll show you. So let's say it is tetrahedral. End of the day, tetrahedral also will involve d orbitals. Okay. So 1, 2, 3, 4, 5. These are degenerate, which means it is the king at this point of time. Cool. Then who approaches? Then the ligand approaches. There's some kind of change. And that change you will show in a different level. So this becomes non-degenerate. Cool. Now what's going to happen? It will split. It will split. Fine. Same old thing. You'll use dotted lines here to represent the levels here. Correct? Now you think the split happened, but it is tetrahedral in nature, which means obviously it will be opposite of octahedral. In octahedral, T2G was at the bottom. Obviously, it will come to the top here because that's how it works. Correct? Both of them are opposite. So T2G will come on top here. But when it comes to tetrahedral, no, you'll only write T2 and E. There's no G. Remember that. You won't write T2G and EG, but you'll remember that way only. So T2 level will come on top, the E level will come at the bottom. Everything else will remain the same. T2G level meaning how many boxes? Three boxes. E level meaning what? 2 boxes. So the same story. First of all, there's a split here. That split is nothing but crystal field splitting energy called as delta naught, CFSE. All those things are fine. But what's the individual number? Very simple. You'll do by 5 and by 5 here. Cool. Now think from E's level. It got defeated. Okay, therefore minus. T2 1, therefore plus. Now T2 had to win over how many boxes? Had to win over 2 boxes. Therefore 2 by 5, delta naught. Now EG got defeated by how many boxes? 3 boxes. Therefore minus 3 by 5 of delta naught. That's your answer. Okay. Do not mug up. So most important thing is when it comes to octahedral complexes, we have T2G and EG levels. But when it comes to tetrahedral, the concept is the same, but you will not write the letter G next to it. Cool. Same story. Degenerate. Okay. Then the ligand approaches. The ligand creates some kind of chaos, some kind of disruption. It disrupts. At this disruption, it is not stable. If something is not stable, the chances of that splitting is higher. It splits up into two things. When it splits up, there's some kind of energy imparted, and that energy imparted is called as CFSE. That's it. So you copy both of them. One of them will 100% come for your exam. Draw it properly. I think magnesium and matter, the notes was I sent on the groups yesterday. I forwarded the thing. More than enough. Okay. It's also marked there, I guess, see there. Two markers, what's important and all those things. If you go through, I think if you spend proper half an hour, do one thing after the class gets over, no, finish that thing off. If you sit in front of that, or because of all the integration which we've done already, nothing is difficult there. See, now you might obviously have to spend a little more time in trying to remember the stuff. And I think you guys read, guys. It's simple only. You find you spend around 30 minutes to 40 minutes. You'll finish off. Okay. If there's any doubt, I think you might get a doubt in one concept. Okay. Actually, in two concepts. Out of those two concepts, one is not there in syllabus. Apart from that, we might get doubt in one concept. I'll explain that later. Cool. But you finish it off today. Spend after the class, spend like around 40 minutes to finish it off. I'll go to the next slide. The title. Again, we are done with the most important parts. More than enough for your final exam also this is. Okay. Along with this, I'm not trying to back off telling only this will come. Along with this, you'll also get something called as nomenclature. That is for one marker. Fine. That can be managed end of the day. You guys get these six things right first. No. Start off with that magnetism and matter right now. Cool. I look for that AC thing. If there's something, I'll let you know. I'll send you. Cool. Fine. See you. Guys, once again, important here. Do not write G. Does not belong. It's only E levels and T2 levels. Cool. Nothing extra apart from that. Fine. Start off with the magnetism part right now.